Hello sir, I am Prajwal Patil from second year aeronautical engineering here to present my ISE activity of solid mechanics on the topic stress transformation in helicopter tail boom structures. So, introduction to helicopter's tail boom. So the tail boom is a crucial beam-like component extending from fuselage of helicopter. Its design is fundamental to aircraft or helicopters' stability and control and acts as primary support structure for the tail rotor and empennage. Its primary functions include support to tail rotor and stabilizers, then transfers load from tail rotor to fuselage and critical for stability and control. Then, what is dynamic loading on helicopter tail booms? Helicopter tail booms are subjected to a complex interplay of forces during flight, which can be categorized into four primary types. First, axial load. Axial load, these results in primarily from direct thrust reaction generated by tail rotor acting along the longitudinal axis to the boom. Bending loads. These are caused by the side thrust of tail rotor, which counteracts main rotor's torque, and the aerodynamic forces on vertical stabilizer and horizontal stabilizer creates movements and that induce normal stress. Then third is torsional load. Torsional load arising from torque reaction of main rotor, which is transmitted through fuselage to the tail boom. This twisting force induces shear stress throughout the boom's cross section. Then shear load. Then fourth one is shear load. These originate from aerodynamic drag, shear forces, and reaction forces that are attached to the boom. Then what are the key stress components in tail boom structures? First, normal stress. These arises from both axial tension, compression, and bending moments. In the tail boom, this means the skin and stringers experience combined biaxial normal stresses. Then second one is shear stress. These results from torsional load, which means twisting and transverse shear forces. Understanding the distribution of shear stress is critical for preventing buckling and delamination in composite structures. Then, what is core of stress transformation? The core of stress transformation is fundamental concept in solid mechanics that allows engineers to determine the state of stress and in a arbitrary plane within the material. So, converting stress orientations. It's essential process of converting stresses from one coordinate system to another, providing an comprehensive understanding of the stress state at an point regardless of viewing angle. Then varying stresses on inclined planes. Crucially, planes inclined at an angle theta to the original reference plane will experience different magnitudes of normal and shear stresses. Then third one is stresses in multiple directions. At any given point with a structural component like tail boom, stresses do not act in isolation but simultaneously in multiple directions. Stress transformation enables a holistic view of complex and multidirectional stress fields. So, understanding the stress transformation equations. So here stress transformation equation is sigma x is equal to sigma x plus sigma x dash is equal to sigma x plus sigma y divided by 2 plus sigma x minus sigma y divided by 2 into cos 2 theta plus tau xy sin 2 theta. Then similarly for sigma dash y. and that is sigma x plus sigma y divided by 2 minus sigma x minus sigma y divided by 2 into cos 2 theta minus tau xy into sin 2 theta. Then for tau x dash and y dash is equal to minus sigma x minus sigma y divided by 2 into sin 2 theta plus tau xy cos 2 theta here. So what are the applications to helicopter tail boom design? Stress transformation is an indispensable design and analysis of helicopter tail booms, particularly for understanding complex stresses in critical components. So, consider a tail boom skin panel located near attachment point. This area subject to multiple simultaneous loads. It experiences axial stress, then shear stress, which result in overall torsional load. Then, using transformation, engineers can accurately determine the stress acting on the various fibers of plies within the composite panel, especially in directions not aligned with global axis. So, why stress transformation is paramount for aerospace structures? So, design optimization. In design optimization, stress transformation enables engineers to precisely evaluate stress distribution. This allows for the design of tail boom structures and that can be withstand with complex multidirectional loading with different conditions and optimal material usage. Then second is fatigue analysis. By understanding the complete stress state, including cyclic stress variations, engineers can accurately predict the lifespan of tail boom. This insight is crucial for preventing premature fatigue failure and a significant concern in aerospace components. Then third is enhanced safety. Ultimately, mastering the stress transformation principles ensure the structural integrity and reliability of helicopters. This scientific approach to the design and analysis directly contributes to the significantly improved flight safety. So the conclusion we get is the helicopter's tail boom is a critical structural component that experiences complex combination of axial, bending, shear, and torsional stresses during operation. So stress transformation is an indispensable tool that allows solid mechanics and aeronautical engineers to analyze these integrate states at any given orientation with structures. This capability is paramount for identifying critical stress concentrations and ensuring design integrity. So, this understanding is not merely academic, it is absolutely essential for robust design, accurate fatigue, and overall safety of helicopter, ensuring they can be operated reliably under any extreme conditions. Thank you.